Hi folks, welcome back to Physics with Captain Rod. Let's see, I'm making this one to help you out with number 28 in your homework. So this sphere rolls without slipping. That's kind of an important part of this problem. It's got a 40 centimeter diameter and a 5 kilogram radius. Let's see, find the acceleration of the center of mass of the ball. So this is going to be a standard Newton's second law type of problem. So first, draw a free body of this object. It should have 3 forces on it. Okay? And friction has to be in this problem, right? Because this thing says it rolls down the hill. If there were no friction, if this were a truly zero friction problem, it would accelerate down the hill and it would stay in this orientation. It wouldn't rotate. Once you get your free body drawn, then write a force equation. Sum of all forces equals ma. Now remember my standard rule of thumb. Identify the acceleration direction, call that positive. The ball is accelerating this way. The center of mass of the ball is accelerating down the incline. That equation should have 2 forces in it. One of them will be in component form. All right, the gravitational force vector you're going to have to break into components. When you get that equation written out, it should have 2 unknowns, right? An unknown frictional force and an unknown acceleration. Next, write a torque equation. The sum of all torques is equal to I alpha. And you're going to want to write that about the center of the ball. So here's the center of the ball. Now if you look at your free body, 2 of the forces that you have drawn, their line of action should go through the center. Therefore they don't create any torque. Only one of the forces that you have drawn should be creating torque about the center of the ball. So this term hopefully should be pretty easy. There is 1 force in your free body that is creating clockwise torque if you have your free body done. And the torque is that force times distance. And if you got your free body done, hopefully the distance is obvious. Okay, this, the moment of inertia, this is a sphere. Go look that up in the handout that I gave you about moment of inertias. Okay, then times the angular acceleration. So I know that we're just getting into the part of the course where we're talking about rolling. But as I mentioned in class last time, at the instant shown, you can actually think of this ball as rotating about that red dot. And then your tangential acceleration is of the center of mass, looks like that. And you could think of the angular acceleration as around this if you want. And then the relationship is your tangential acceleration, I'll go ahead and tell you what this one is equal to r times your angular acceleration. So that should give you enough to put things together, hopefully, and get that problem solved. I hope that this helps. Have a great day.